row, third row. Third row, 5 students here come. And 1 from this row come. Yeah, you two come. Yeah, come soon. Before the stage should be covered. Yeah, all the boys are covering now. Huh? Okay, it is very good. And you see whether all are homogeneous data? All are boys now? So homogeneous data items. So how they are standing? Huh? They are standing adjacent to each other. So I am going to give a name to this data set. I am going to have this as an array. So what name we can give? Yeah, this is your choice. Tell me a name. Yeah? Huh? Ankit. Yeah, Ankit. So the name of the array is Ankit. Okay. Now Ankit array has 6 elements. So which is the first element, first data element? Yeah, I need your notebooks. Write some integer data, the notebook, and give it to me. Yeah, fast. Keep it. Next note. Yeah, next note. Should be visible. See, first data is 10. Second data is 24, third data is 4. Yeah, far. Fourth data is 30. Fifth data 5. One more notebook. Okay, one more notebook you. Write the data. Hand over to them. It should be visible. Write in big size. Haven't listened at all to the stage till now. Okay. Show the data to everyone. So I have now 6 data in the list. Okay. The first data is 10, 24, 4, 30, 5, 7. So which is the first data? This is the first data. 10 is the first data I am assuming. So this is the first data. The name of the array is Ankit. So how can I access the third data now? Can I access directly? Now what is your name? No, I am not asking your personal name. Okay, now you are standing in Ankit array. In Ankit array your name is Ankit bracket 2. Okay, your name is Ankit bracket 5. No? Yeah, right. So Ankit bracket 5 is the last element. So how can I access the element? Just by directly calling Ankit of 3, Ankit of 4, Ankit of 5. I can directly call them. Okay. Now Ankit 4 come forward. Go back. So how do I traverse now? How can I traverse from the first to the last? You think of C language and tell me. How will you write the coding? Yes. And how to? Use for loop. I have to start from. The index should start from 0. Yes. Ankit of 0. Ankit of 1, Ankit of 2, till from 0 to the last element. I can traverse from one by one just by incrementing the index. Is it not? I has to be incremented to I plus plus. That's all. How will you traverse from the last to the first? How will you print the array elements from the last element to the first element? In the same for loop, you have to start the indexing from from the last element. Okay, from the last element you have to decrement I one by one to come to the first element. Okay, so this is traverse. Now how will I add a new element? How will I add a new element? There's one more, the last one. No, wait. You come. Insertion. How can I do the insertion in an array now? Where do you want to get inserted in this array? The third position. So he wants to get inserted, or I want to add this new data into the array in the third position. So what I have to do? How he can be inserted? So I have to first find out. I have to go to the third position. So I have to start from the first element. So come to the first element, checking the position, whether the position is 3. Okay, position 3 now. Yes or no? No. So you have to move forward to the next element. Position is 3. No. Again you have to move forward to the third element. Position is 2. So again 3 not equal to 2. I have to go to the next element. So what I have to do now? This position should be empty, is it not? So insert into. So what this element has to be done? The last element should move to the next successive position. It has to move successively. Now this position is now empty. I can seat him in this position. So insertion is done now. Okay. So my array should have been declared with the. If I have declared with the correct size of 5, then I cannot be able to insert a new element. So I have to, while declaration of the array, I have to take care that should be able to accommodate the new elements which can be accommodated in future. Okay, so this is one disadvantage of array. This is the static memory allocation. So you are declaring the array at the starting itself, the size is declared. So the fixed memory allocation is done during the compile time. So during the run time, if I add more data, we can go for adding more and more data each and every time. I have to check whether the array is full or not. Only if the array is not full, I can do the insertion. Only if I have empty elements, empty spaces, I can do the insertion. Otherwise, I cannot do the insertion. So this is one disadvantage of array. Okay, I have done the insertion now. This is insertion at the middle of the array. Insertion the first element. How will you insert as a first element? The same procedure, is it not? You have to check the position. You have to get inserted. If it's going to be inserted in the first element, what has to be done? All the elements in the list has to be moved one step further. If it is going to be inserted as the last element, no need for the movement of the data. You can directly go for the last cell. If that last cell is empty and if this memory size is already declared in the array sufficiently, I can just keep the last element in the array. Okay. Insertion we have seen. Next, deletion. Now what are the data? 10. You need one data now. Give me your notebook. Write some data. 15. So 15 is the new data inserted at the position 3. Okay. Now which data you want to delete? Which data you want to delete? Yes. 10 data has to be deleted. 10 where is 10? 10 is the first element in the list. So list ADT we are seeing the implementation of list ADT using arrays. Okay. So how will you delete the first element from the array? Yes. Again traversing. So first I have to move to the first position. I have come to the first position. Okay. Just like how to free this space. Okay, just go to your place. Thanks, love. Now 10 is deleted. Wait. So what has to be done with this empty space? Okay, how to move all the other elements from the list to move a step prior. Yes, move. Now the size of the array is now reduced from 7 to 6. Okay, you understand how we have to do it? Suppose I want to deleting a middle element means it has to be deleted. That particular memory element has to be freed up, and then all the successive elements, they have to be moving one step previous. Okay, so you understand the insertion and deletion operations. Now I want to read the fifth element. I want to print the fifth data from the list, from the array. How will you get the fifth data? Fifth data, what's the name for fifth data? The index starts from 0. The name of the fifth data is Ankit of 4. Ankit bracket 4. So I can just print Ankit bracket 4. It will print the fifth data. So reading the data is easy. Is it not? I can directly call the name. I can access them. What about insertion and deletion? Can you directly insert? Can you directly delete? What we need to do? In each and every insertion and deletion operations, what happened? What happened? Okay, what we have done now? Data movements is there now. Either to the left or the right, you are moving all the data based on the position you want to insert or delete. So what about the time taken for all these data movements? So the time complexity is more for insertion and deletion operations. What about the time complexity for reading the data? For reading a particular data, I can directly read. No data movement, is it not? I can directly call them by name. So the time complexity for reading, for accessing the data is less. That is the advantage of array. Data access is easier, but insertion and deletion is costly. Understood? What are the other operations we have to see? Sorting, searching. So suppose you want to search for a particular data. Okay. Suppose I want to search for 30, the data 30. How will you do it? Data 30. Yes, I have to start from the first element. I have to check whether data 30. 30 equal to 24. 30 equal to 24? No. So I will move to the next data. 30 equal to 4? No. We'll move to the next data. 30 equal to 15? No. We'll move to the next position. 30 equal to 30? Yes. So the data is found out at which position? Which position is the list? Position 3. Okay. And what are the other operations you can see? Yes, sorting. How will you sort the data? Now see the data is 24, 4, 15, 30, 5, 7. How will you sort the data? Any algorithm? Each and everyone can come out with your own algorithms for sorting the data. So many sorting algorithms are there. Okay. So we'll see it later in the class. It is in the syllabus. Okay. What are the other operations? We have taken the list of operations and we have got all the operations. Reading the data, printing the data, traversing from first to last, last to first, insertion, deletion, searching. Okay. Merging. How will you merge two arrays? How will you merge two arrays? How will you merge two lists? Yes, we have to declare two arrays. This is not two different arrays or two different lists. We have to make them into You have to declare your third array with the required size and you have to just place the elements as it is. Okay, so understood? So list edit is okay. Yes, thank you boys. Thank you. Can go to your places. Yeah, how will you update the data? Modify your data. Suppose you want to modify 10 to some other data. Then you have to find out the data plus whether it is present in the list. You go to that particular data. After finding the data, you have to just replace it with its name. A of 5 equal to 50 like that. A of 4 equal to this one. That's all. Okay. So any doubts in list editing? Any doubts? Understood well? Shall we see the coding? Now you see this is an example, okay? A list of size 5 implemented using an array. The name of the array is A and the elements are 20, 10, 30, 40, 50, 60. Now how will you declare an array? No. Now how to create an array? See the coding. See the coding. How to create this list ADT. So what is done? You have to get the number of elements to be stored in the array and then get value of the elements to be stored. Just simple printf scan. Okay. So the array will be created with the declaration of here like this one. Now the name of the array here is list. Okay. So if you have given the number of elements as 6, you have given these values as, then this array will be created. So again it is homogeneous collection of data items. The elements will be placed adjacent to each other in memory. The memory will be allocated for the array during which time? Compile time or run time. For array, the memory allocation will be done at yes, third row. Tell me, use that now. You are seeing your mobile. Stand up. Memory allocation is done at which time in array? Memory allocation is static or dynamic in an array. Static. What are you saying it is static? What are? Fixed size. Sit down. So what do you mean by static dynamic? Refers to compile time or run time. Static means during compilation. Dynamic means during running. That is the execution of the coding. Okay. So you have done all the 3 exercises in the lab now. C++. Now how are you running it? Before running, during the compilation, it will list out all the errors. If there is no error, it will run successfully and give you the output. So during the compilation, memory allocation will be done. So that is static memory allocation is in array. For linked list, that will be dynamic memory allocation. So we have seen static memory allocation using arrays. Now insertion operation. Now you see the coding. Insert. Here no parameters for the insert function. So the data to be inserted, I have given the input for the data to be inserted and the position at which the data has to be inserted. Okay. So what you are doing? You have to check whether for insertion we have to check whether the array is free enough to accommodate a new data. So you have to check whether the array is full or not. Okay. So if the array size is 5, I am going to give the position as 8 and I have to enter the new data in the 8th position. The array size is declared as 5 only. Can I do it? Can I do the insertion? Hey, everybody is sleeping. The array size is 5. Okay, how many boys have come and stand here? 6 boys, sit down. I want to enter a new data in the 10th position. Can I do it? No, why? The array size I have declared only 5. 0 to 5 means I can accommodate only 6. I cannot insert a 10th element. I cannot insert a 7th element. Only from 0 to 5 I can accommodate. So you have to check that condition first. Whatever position you are giving, whether it is less than or equal to your n. Only if it is less than or equal to the size of the array, I can do the insertion. Otherwise, I have to say array overflow. And then using the for loop, we have to just move to a particular position, either successive or to the predecessor, depending on the position you want to insert. So go through the coding, and then you have to place a new data in the particular position. You have to increment n, that's all. Understood the coding? Any doubts? Any doubts? Can I am asking? Because coding is very, very important for your placement. In this third semester, you have to practice during your lab sessions very effectively. Don't miss your lab session practices. Don't get absent yourself. Okay?